So welcome back. We have just seen that tuples and records are very nice, but they suffer from a major drawbacks. Their size must be statically bounded. And sometimes when you program, you cannot predict how much data you will have to process. That's exactly what arrays are good for. You can define their size dynamically. In exchange for this new feature, all arrays elements must have the same type, contrary to tuples on records in which subcomponents can have distinct types. So here is how you defined an array whose size is statically known, and it has 3 elements, 1, 2, and 3. So you can notice that OCaml is able to infer that the type of this expression is indeed an array containing integers. So let us define a function that takes an x and return x multiplied by x. We can use this function to initialize an array of size n with the property that at the index number I, we will see I multiplied by I. So we can define such a function and then apply it to 5 to see that we have the first 5 square, and also can apply it to many different values like this to get different arrays of different size. So to sum up what we have just seen, there is a type for array whose elements have some type, and it is written some type array. Array is predefined in OCaml, and there exists a module in the standard library that will provide you several functions over arrays. So this syntax is okay for small arrays whose size is known at compile time. But now, if you don't know the size and you have to compute it, you can use a function named array.make that will expect an integer representing the size of an array and a value that will be used to initialize each component of this array. There is another function to initialize arrays which is very interesting. It is called array_init, and it also expects an integer that represents the size of the array you want to create, but also a function that will be used to initialize each component of this array. This initialization function is given the index of the component, and in exchange must return the value that may depend, of course, on this index. A very useful function is the array.length function that returns the size of an array. Now, if you want to observe a particular component of an array, you can do it using an index, an integer that represents the position of this component of the array. To do so, you write your expression that represents the array, dot, an open parenthesis, and then an expression that evaluates into an integer that represents the index, and finally, a closing parenthesis. You have to be careful because the index of an array must be taken between 0 and the size of this array minus 1. So now, if you want to observe several components of an array at the same time, you can use array patterns. Again, you use the same syntax as with expressions, except that you replace expressions by patterns. We will see that array patterns are not very convenient when you program. So let us define a function that takes an array as input and return an array of size 2 containing the second cell of the input array as the first cell. So it's a cell numbered 1. And in the second cell of the outputted array, we will put the content of the first cell of the input array, so the cell numbered 0. So the type of this function is array to array, and it is polymorphic with respect to the type of the element of the array. Now we can check that it indeed works. So let us try to use the array patterns to define a function called swap. This function takes an array of size 2 as an input and name the first cell x and the second cell y. And it will return an array containing first the content of y and then the content of x. So let's see what the compiler is responding to that definition. So this definition is accepted, but a warning is issued. And it says that this pattern matching, so the way we have defined the observation of our input argument, is not exhaustive because, for instance, an empty array is not matched by this pattern. And indeed, even if my function is working on an array of size 2, it will crash if I give it an array, for instance, of size 3. So array patterns are not very good when you are using them as argument of a function. In the machine, an array is represented exactly as a tuples and exactly as a record by a heap allocated block. Now, what kind of programming error you can do when you manipulate arrays? Well, the first one is to mix in the same array values of different types. But fortunately, that kind of errors are caught by the type checker. So if you try to put two values with different types in the same array, you will get an error from the type checker because it's expecting all the elements of an array to have the same type. Another kind of programming errors that is very common but is unfortunately not caught by the compiler is an invalid access to a cell of the arrays. Indeed, the compiler cannot predict if some expressions will evaluate into a valid index of the arrays. So if you get a negative index or an index that is greater than the length of the array -1, then it will crash the program. So consider the definition of an array of size 3. If you try to access a cell number 3, so just after the end of this array, you will have a crash. If you try to access a cell indexed by -1, again, you will get a crash. And the compiler is unable to predict if you can do such a mistake.